Find the point of intersection of the plane 3x plus y minus 2z equals 7 and the line x minus 2 over minus 1 equals y minus 1 over 1 equals z plus 3 over 2. So, there is a plane in space and the plane intersects a straight line at some point. Now the problem is to find the coordinates of the common point. So let the common point be P. We need to find the coordinates of the point P. Now the line equation is x minus 2 over minus 1 equals y minus 1 over 1 equals z plus 3 over 2, and the plane equation is 3x plus y minus 2z equals 7. We have to get the coordinates of the point P. Now, the line equation contains three ratios which are equal to each other. So, by equating each of these ratios to some common number, say r, we can equate each one to r and express x, y and z in terms of r. So, let us equate each ratio involved in the line equation to r. So now, x minus 2 over minus 1 equals r implies x is minus r plus 2. Then, y minus 1 over 1 equals r gives y equals r plus 1. Next, z plus 3 over 2 equals r becomes z equals 2r minus 3. So, we have got one set of conditions connecting x, y and z through a common value r. Now, as r takes various values, we will get different sets of values for x, y and z. Say for instance, if r takes the value 3, then by substituting for r as 3 in x, y and z, we will get a specific point which can have a position on this straight line. Say for instance, let us take r as 3, then x is minus 3 plus 2 which is minus 1, then y assumes the form 3 plus 1 which is 4 and z takes the form 2 times 3 minus 3 which is 3, which means the point 1, 4, 3, it has a specific position on this straight line. As a matter of fact, as r assumes values right from negative infinity to positive infinity, assuming all real number values, the points on the straight line are completely exhausted. In other words, r, which is involved in these three equations together, is the generator of the straight line. Therefore, r is a parameter and it should not be mistaken for a constant. Now, we need to find the coordinates of the point P. P is a point on the straight line. Hence, for a particular value of r, this variable point x, y, z will coincide with the point P. So, let us assume the form of P as minus r plus 2, comma, r plus 1, comma, 2r minus 3. Now, we need to evaluate r. For finding r, we have to establish a condition connecting the given data. Now, we have recognized P as a point on the straight line. We can visualize P as a point on the plane also because P is a common point for the straight line as well as the plane. So, in that case, when we substitute for the x, y and z of this plane equation, these coordinates, the equation should be satisfied. What do we mean by this? When we replace x by minus r plus 2, y by r plus 1 and z by 2r minus 3, the left hand side of the plane equation should balance the right hand side. So, let us replace x by minus r plus 2 and y takes the form r plus 1 and z assumes the form 2r minus 3. So, this has to be balanced by the right hand side of the plane equation, which is 7. Then, let us expand it. So, it is minus 3r plus 6 plus r plus 1 minus 4r plus 6 is 7. Then, we can club the r terms. Minus 3r plus r is minus 2r, minus 2r minus 4r is minus 6r. So, it is minus 6r. Then, grouping the constants, 6 plus 1, 7, 7 plus 6, 13, 13 minus 7 is again 6. So, plus 6 is 0. So, this is a simple linear in R. So, we can effortlessly solve for R and we get the value of R as 1. So, now, this value of R, it has to be substituted for the x, y and z values of P, right. So, now P takes the form minus 1 plus 2, comma, 1 plus 1, comma, 2 times 1 minus 3 or that becomes 1, comma, 2, comma, minus 1. So, that is, we have got the common point P with coordinates 1, 2, minus 1. Now, let us have a quick recap. From the line equation, we can extract x, y and z in terms of R and use these values of x, y, z in the place of the plane equation 3x plus y minus 2z equals 7 and solve for R. And substituting for the particular value of R here, we get the coordinates of the point P as 1, 2, minus 1. That is, by solving the two simultaneous equations, that is the line equation and the plane equation, we get a common solution and the common solution itself is the common point for the line and the plane.